Hello and welcome everyone to the last section in which we will discuss and we will do hands-on in Python. So we'll try to do each and every steps that we have learned in across different modules of statistical analysis. We'll be very brief in this. I will just show you one line of code just to do how quickly you can do the hypothesis testing, how can you do the sampling intervals, those kind of things I will show you from start to end. But we'll keep only simple chunk just for your demonstration. If you would go like in the detail would like to go in the detail, then you can go and check the another module 5.4 of Python module, in which I have shown in detail like how you can do the statistical analysis in Python. And if you would like to explore, you can explore each and every section in great detail. But here I will show you some of the demonstration. So in this module, the first thing is let's start with the data. So again, before starting with the data, sample data, you need to import the libraries. So you need to import the libraries like numpys, pandas again for the numerical operations, file loading, handling, scipy, matplotlib for visualization, c1 is also for the visualization. We are generating a random data set here, like we are giving the random data frame. We are including the data in which we have a sales, we have a marketing spend, we have a reason information, and the clicked information. Okay, this type of data frame we are generating for the four columns, multiple instances ranging from 100 to 5000. Okay, we can quickly see the data head, how this data looks like. So data will look like we have a sales number, we have the serial number, we have marketing spend, reason information, and the clicked information on that data. Now for the descriptive stats, that's the very first section that we have discussed in throughout this class. You can either calculate mean, so you need to define the column, define the data, define the column. For the sales, for instance, you would like to compute the mean, dot mean, and you will get the mean values. You can get the median values, mode values, same. If you would like to see the spread, then you need to calculate the variance, the overall variance in the data. Take again the sales column, compute the variance, you will get the spread. At the time of spread, when you are showing the variance and everything, you need to show the standard deviation also, how the data points are deviating from the actual mean, median. So those standard deviation also you can get. Then interquartile range, if you remember, we need the mean, mode, median, variance, standard deviation, interquartile range. By using these interquartile range, using the mean, using the standard deviation, we can compute and calculate the outliers. We can get the percentiles also, like 25 percentile of the data, 75 percentile of the data, and 75 percentile of the data. And then the quick visualization plot by doing the sales histogram, data, sales, and histogram. By this, you will get the perfect sales distribution across the time points. If you'll run these commands, you will get the mean, median, mode, variance, standard deviation, QR, 25th, 50th, and 75 percentile, and the perfect distribution of the data, in which you are getting mean somewhere in the central. So it looks like it's a normal type of distribution, but you can check the skewness and all those things that we have discussed. Sounds good? Perfect. Second section, if you remember, we discussed about the probability essentials. And probability essential we are getting from the data, and we are checking the clicked, how many clicks are there. So we are getting the mean. So we'll get the probability for the clicks first. Okay. And if you remember, in the probability, we learned multiple concepts. One is either there is one event and there is opposite of the events. Probability you will get between 0 to 1. Then if you are getting the sum of the probabilities, then you need to at least subtract the common that you can find. Those things we have discussed, you can check quickly here. Then normal distribution, if you are getting for the x PDF, you are getting something like this, then you can plot the normal distribution. Then you can plot the binomial distribution. For the binomial distribution, you can take the ranges and p, define the range, and quickly the stat plots for the binomial distribution. So you can plot normal and the binomial distribution for the probability range that you are getting. So probability range, normal distribution, you are getting probability of click is 0.54. That means probability of non-click is 0.46. Always 1 minus probability of. For normal distribution, you will get something like this. For binomial distribution, you will get something like this. So data points you will get. Okay. For each range from 0 to 10, you will get the data point something like this. You will get the density specifically in terms of the distribution. Probability is very simple. You need to understand these concepts, because sometimes you need to understand what this probability mean, where you can use in throughout your data analysis. Then you go for the sampling and intervals. Now you need to identify. So in the sales data, you do the sampling 30, you print the sample mean, and then go for the central limit theorem demonstration. So we are getting the sample means from the data cells. In sales 30, we are taking the mean range of 1000, and then we are making a histogram of bins 30. For 30 wins, we are creating the histogram to get the count of the sales in top 30 wins. And then we'll take this as a sample distribution across the mean. Once we'll get the sample distribution again in the histogram, then we can get the confidence interval. For the confidence interval, you need to compute the mean for the sales. You need to compute the stats for the sales data. Once you will get the stats and so you get the means using the mean and the statistical this stats, by using this data you can get the stats t interval. You can define here as you want 95% of confidence interval, 98%, 99%, or how much interval, how much interval confidence interval you want. Okay, you can define the location, you can define the in the scale that you are using here. And by using the location, this you are using the mean and you are using the stats that you have computed. By this you can compute the confidence interval, which is 95% in this case. So this is also a data. You get the sample mean, you get the sampling distribution across the mean, and then you get 95% of confidence interval is the lower value is 471, which is somewhere here, and the higher value is 507, which is somewhere here for you. Okay, so this is your confidence interval. Whatever you are getting beyond these points, higher or lower, which is outside of your confidence interval. So this is also very important to compute and calculate. Then you go to the hypothesis testing. Hypothesis testing is very much important and very good to quickly test whether the differences you are seeing are significant or not. We discussed about the one sample t test, we discussed about the chi-square test, we discussed about law. So for the t test, you will do the sample t test, data sales, and you will get the t test statistics. For chi-square test, you are doing the region versus clicked, so you are getting cross tab between region and clicked, so you will get a confusion matrix. For region tabs you will get certain numbers, then you will expect the numbers, then certain numbers minus expected number, we discussed the formula, you will get the chi-square probability for that. Contingency you can directly visualize in the heat map. So you can do the t-test. In the t-test, in the sales, is there any difference? P value is 0.25, there is no differences. In chi-square also, p value is 0.43, that means there is no differences. The chi-square is here. For the east, north, and south and west, you have the region information and you have the clicked information, either 0 or 1. Whether there is any differences between the region and the clicked across the region, so there is no differences, you can compute by the chi-square test. Then you go for the correlation. You remember we do for the simple association between two variables. So bivariate analysis, you're trying to identify any, is there any association between sales and marketing spend. You can simply use the core function to get the correlation. If there will be any correlation, you can quickly make a scatter plot, and in that you can see if there is any association, if there is a positive or negative association. So quick scatter plot is here. I don't think there is a any association, specific association, but you can quickly check the sales and marketing association. It looks like negative but not very strong, very fine negative association. That means marketing spend is increasing, the sales are decreasing, but the association is not super strong because the value is closer to 1, the association is strong. Value is closer to 0, association is not that much strong. Then you go for regression. Again, simple linear regression is the first thing. You use the stat models for that. You are using marketing spend, and the sales is your target variable. You do the constant add for the x value. You do prepare the model by using the target and the features and fit model, and then you can do the model summary and you can plot the regression plot. So ultimately, when we do the model summary, we get the r square value, adjusted r square value, p values, and everything, whether this is significant or not. And this is your regression line or regression information. Slight decreasing, that means slight negative association. When marketing spend is increasing, the sales are decreasing, but this is not a strong positive association. And even we can check from the significance, the marketing spent significance, it is not significant because the value is 0.176, not less than 0.005. R square also is 0.001. That means like R square value should also be between 0 to 1. 1 is the stronger association, stronger correlation or regression, or 0 is the lesser association or no association, I would say. Then you go for the regression 2. If you remember, we discussed about the multiple regressions. When you are not trying to find out the association between two variable, instead of you are trying to find out the association on the sales of effect of different regions. So you want to check the effect of marketing spend, region east, region north, region south, region west, everything. You can include as many as variables you want. So you want to check the effect of this on this, like association of these variables onto this. So first we are converting the reason into the data dummies, like just drop whatever is not present in the first. Once you will get the data dummies, you will get this number, and then you will use the x as your feature variable and buy again as a target variable. Target variable is again sale. So association with the sales to check the effect on sales of the marketing spends, region east, region north, region south, and region west. You can even use the combination of two variables, combination of three variables to check the effect on the target sales. Again, you will use the same thing. You have the x, which is feature, and you have a buy, which is a target variable. You will use fit, the similar kind of variable. The only difference is now in the x multiple variables instead of one, which you were using in the linear regression, which was the marketing spend only. Here you have used multiple variable. Try this, try different kind of variables at this point and check what kind of error you are getting. If you're getting the missing values in these region, fill it. If you are having categorical variable, do the encoding, convert it into the numerical, or change this with the numerical values that you have in the data, and try this logistic regression, multiple regression, and try to understand how you interpret, how you will interpret the results, like association of one variable with the target variable, association when you're not considering other variables, or the effect of other variable you are considering as a zero. Explore it, make multiple plots, and try to find out what you get here. Then we'll go to the experimentation, which is A/B testing. We are dividing a group A and group B. Group A have certain number of instances, group B have certain number of instances. We are doing the t-test, like between the t-test individual, between group A and group B, we will get the t-test statistics and the p-values. We'll do these kind of t-test statistics. You know the differences. A is the blue and B is the yellow, and the violet color that you are seeing in the middle is the intersection. Is there any difference between the A group A and group B? Yes. T statistics shows minus 2.3, p value is 0.02, which is less than 0.005. These kind of statistics you can do when you are comparing multiple groups at a time. Then we'll go for the time series basics. We discussed about the time series. Time series, when you would like to capture the trend, seasonality, and anything in the data, you are defining the start date range from the monthly fashion. You are getting the start date range, and then you will just plot it in the time series man. So this is a time series for you. Like you are just doing from January to October, and you are seeing, let's say, the sales or any amount on the y-axis, how it is increasing or decreasing. And the same thing you are doing for the other plot also. You can do the 3 months MA, or you can do the multiple months MA. This is completely up to you. This time series data you use for the forecasting. So in the forecasting, if you remember, we discussed three methods. Nave forecast, I'm just giving you the example of Nave forecast here. You can try other methods also. So in the Nave forecast, you can simply take the mean average that we discussed, the running average of the past events to compute the future forecasting. And that is a very simple method. You do NP repeat sales item log. You are taking -1 to 6. So you are taking the seven days forecasting. You're plotting the actual and the forecasted values here. So this is your dates here. You can modify the dates. Just x-axis you are labeling like this. You can just do this 45-degree angle. The forecasting, you will get something like that. Your actual values are like this. If you will predict for the further month, at the end you will get the values something like this. Now you need to make sure, you need to infer whether those values are making sense for your project, for your data, whether those values have enough confidence interval, less uncertainty, or more accuracy. If this forecasting or predicted data is making sense, or there are anything that is changing, like based on the seasonality, or based on any cycles, or based on sudden drop or sudden increase, that factors like that, those trends or those seasonality information, if you need to include in the model, you can go and repeat the other models that we have discussed apart from the nave forecast. Or you can create multiple models and compare the performances. The compare the performances you will do by the mean squared error that we discussed. Less the error is, perfect the model is. Then hands-on and combined practice that we discussed everything. You can just keep on repeating these things again and again. Try each and everything. So go here, from the descriptive stats to probability essential, sampling method, hypothesis testing, try each and everything in the Python. I just gave you one example with the data. I would expect you to try each and everything that we have discussed in the every module. So in every module, if I'm showing you three different methods for the forecasting, in the example I just showed you the name method, you can try the rest too also. You can use the same data, try all these three methods, and then provide the information which method is performing well for your dataset. This is just for the practice, just for your learning. Whatever you are seeing here, what you get actually when you do write those codes for the statistical testing in the Python. If you want to check this in detail, you can follow the module 5.4 in Python class, where the detailed statistics also covered again. Perfect. Thank you so much. And this course is complete.